Channel morphology is a new chapter introduced in civil services during recent years in geomorphology. Channel morphology consists of two words. First channel, then morphology. What is channel? It is a common word used by the people for televisions, mobile sets, etc. And people change channel to view and different things. But these channels carry informations, but they don't develop any type of topography and landform. Channel term is also used in oceanography, where through a narrow strait the water flows at a very fast rate. For example, English Channel. But that channel also does not develop any type of landform, or there is no morphology developed by that channel. Here, channel morphology will be studied in geomorphology, and channel stands for moving water on the land, carving erosional and depositional landforms. Morpho means form. That channel develops erosional and depositional landforms, and logy means how the channel develops landform. Its scientific study is logy. Thus, channel morphology is a geomorphic term which defines the scientific development of landforms from the source of a river to its mouth. Channel morphology has three perspectives to study. Number 1, channel geometry. Number 2, channel flood dynamics. And number 3, hydraulic geometry. Number 1 is channel geometry. Geometry means different shapes like triangle, rectangle, square, line, tartagus line, etc. And if we go in history, we will see that geometry started in Egypt on the basis of the study and maps of river Nile, which changed its course, and a number of linear patterns were developed by the river Nile. That's why here channel geometry means we will study from the source to mouth different geometrical shapes, wherein number 1 is length. In length we measure the distance of a river from its source to mouth, and there are two lengths. One length is geographical, the other is actual. If you want to measure actual length of a river, you will have to stretch a rope from mouth through the mid of this valley to the source. In this, there may be waterfalls, cataracts, and rapids, which are vertical landforms. There, the length of rope will be elongated, with the result, if you will stretch that rope, its length will be longer. Contrary to it, the geographical distance, this river has also geographical distance, wherein we measure its distance on a map, topographical sheet, or landsat imagery on the basis of scale with the help of thread and scale. It means that geographical distance is less because there waterfalls and rapids are shown in a planimetric way, not altimetric way. Thus, the real or actual distance or length of river will be more than the geographical distance. Second is bends. Some rivers flow from source to mouth and follow a straight path. Contrary to it, some rivers make bends, and bends are actually meanders which are found in plains. Why bends are there? Because that has gentle slope and large amount of sediment and water. Next is effluent river, which is in humid region. Effluent means all water amount in that channel is throughout year. because that is rain fed and glacial fed, while in fluent you keep the spelling of these two terms: effluent in humid region, influent in arid region. In arid and semi-arid region, there is less amount of rainfall. That's why during rainy season, these are locally called wadis, bear some amount of water and channel flow. In remaining seasons, the bed is dry. So, in this model, we can see some parameters of channel geometry. For example, this is channel width. Channel width means this is a river, this is a valley is a landform, and if here water is flowing, that is called river, and the channels are also the flowing water. River is a common word, valley is a geomorphic term, and channel is also a geomorphic process. Thus, the width of this river is from this bank to this bank. Measurement of this width varies from season to season. For example, if you see this valley during lean period, when there is less amount of water, this is underbank. Underbank means this is river water level. So, during this period, the channel width will be measured from point A to point B. But when there is sufficient rainfall, full bank river will be found, and then the width of river or channel will be measured from point A to B. And during flood hours, when the capacity of river is less but the flowing amount is more, then this is overbank position of a river, and the channel width is measured from point A and point B. That is the widest. So, this is the first measurement, channel width. Now, the second measurement is channel depth. Channel depth is also a very important parameter because it is measured at the deepest point, or say valley thalwest point. But to calculate its discharge, we measure this channel depth at several positions. For example, channel depth at this point, channel depth at this point, several points, and we take average of those and then calculate the discharge ratio and velocity on that basis. And this is side slope or bank slope. Bank slope sometimes is steep, sometimes gentle, and here is channel bed. This bed may be rocky bed or alluvial bed. So, this is a slope. There are two aspects of slope study in river. First is from the source of a river to its mouth. That is called longitudinal slope. Sometimes in youthful stage, this river here drains through our mountains. Then here slope is very steep, and in plains near delta, slope is very gentle, 4 to centimeter per kilometer. For example, in Gangetic plain, in Brahmaputra river, about 12 centimeter per kilometer. It varies from place to place, river to river. So, this is the longitudinal slope of a river that decides the ratio of erosion by the river. Second slope is this transverse slope or across slope. For example, if you want to travel along a river from its mouth to source, make a journey, you will have to accomplish longitudinal journey. If you want to cross river across or transverse way, then you will have to get down along this slope and then travel on this channel bed. If it is dry, then you can cross this river. For example, Tulsidas during midnight thought to meet his wife. Then can you tell which river he crossed, whether it was Ganga or Jamuna or Mississippi. Now, you should be a good scholar of geography, should know location of Tulsidas residence, then you can answer. And if he crossed, then that Jamuna he crossed along the longitudinal course or the transverse way along this slope. Likewise, when Lord Krishna was born, Father Vasudev also tried to keep him away, and he also crossed not in a longitudinal way, rather in transverse way. Which river he crossed, keeping Lord Krishna on his head? I think it was Jamuna or Ganga. You go through these literatures, and thus he crossed river Jamuna along the transverse course, a cross section. So these are the different aspects of channel geometry. In channel geometry, there is one more term, thalwege or wily thalwege. Thalwege or wily thalwege. Thalwege means in this river during summer season there is minimum amount of water, and that water flows along the bluffs or along the meanders. So if there is some fish in ocean and that fish has to travel along this river and reach near the source, and whether that fish will move through the deepest waters or it will directly move through here point bar deposit or through our sand. Answer is very simple, that the deepest waters that fish will follow. It means wily thalwege is the line joining the points having the deepest waters in a river. For example, this is a wily thalwege which is zigzag. Although this is a meandering valley, but wily thalwege has developed more meanders or it is more tortuous. So wily thalwege is very important geomorphic term today. It should be understood very clearly, because in political geography its concept is basic. For example, let us take one example in India. Here this is Bangladesh and this is India, or say West Bengal state of India. Between Bangladesh and West Bengal there is a river Haryabhanga. Haryabhanga is distributary of river Ganga, and Haryabhanga drains into Bay of Bengal, making border between Bangladesh and India. Just at the mouth of river Haryabhanga there is New Moor Island, which is dispute between Bangladesh and India at international level. So in international relations, IR or international geopolitics, this point is to be made clear. For example, this Haryabhanga has a river valley, it has channel, it has valley thalwege. So the political boundary is decided through the mid of that river valley, but the real boundary is being made by valley thalwege. And these days valley thalwege means the line joining deepest point of that valley, means valley thalwege is shifting eastward. With the result, India is claiming that this New Moor Island belongs to India, because the east shifted river Haryabhanga has carried down, transported the sediment of India or alluvium of India, and that New Moor Island is made up of Indian alluvium. That's why India's claim is right, and on that ground India has captured this New Moor Island, but Bangladesh continuously opposes it. What is your decision if this valley thalwege of river Haryabhanga is shifting east, it means nature is with us, with India. It means river Haryabhanga is cutting, eroding the land of Bangladesh and giving it, handing over it to India. India is lucky because geography of India is very strong. On this, Bangladesh is opposing, but India says that what can I do? If river, nature is cutting your land, giving it to me, what I can do? You take any step, but Bangladesh can take no step. Why? Because this river Haryabhanga will continue shifting its valley always or riverbed eastward. Why? For this, you will have to open the pages of Indian plate tectonic or geophysics, because here this is the largest geosyncline developed on this planet Earth, that is Ganga geosyncline, and voluminous amount of sediment is being brought down by Ganga and its tributary and is being deposited in Bay of Bengal. Due to it, this part along the Dhaka is subsiding. Due to its subsidence, naturally the bed of or valley thalway of this river Haryabhanga is shifting east. That's why India is geographically very strong. This you will study in political geography or geopolitics or international relations. The same is the case here, taking a valley thalways in Sar Creek. Sar Creek will be studied in detail while studying Gujarat and international dispute between India and Pakistan. But in short, Sar Creek extends from north to south, and there is a small stream draining from north to south. That stream also has a valley thalway which is shifting its bed westward and capturing the land of Pakistan and handing it over to India. India here is also very lucky, geographically very strong. Why these two rivers are doing partiality with India? Why nature is with India? To understand it, you will have to open the pages of Indian geophysics or plate tectonic. As you know that the western part of India is rising up. If it will rise up, certainly the eastern part means this geosyncline and the western part of Indus geosyncline will subside. And if this and this will subside, certainly the rivers flowing from north to south here, Sar Creek also will shift their bed or valley down slope. Thus, the rivers Haryabhanga and Sar Creek are shifting their bed, and India is in very advantageous position. So, this is about the channel geometry. It has a physical or geomorphic aspect, as well as you have seen, it has human aspect, social aspect, economic and political also. That's why geography is an interdisciplinary subject, multidisciplinary subject. That's why you should study these points very clearly in detail. The second aspect of channel morphology is channel fluid dynamics. In channel, there is liquid water, not solid or ice, and that fluid also has dynamics. Dynamics means it is not stationary, rather that water flows and that erodes river in headward, vertical, lateral and mouthward. So this is fluid dynamics. To calculate fluid dynamics, we have to study two parameters. One is discharge, second is velocity. How to measure discharge of a river? Suppose this is a river. For discharge measurement, you have to compute water volume. For computing water volume, you will multiply this channel width with this channel depth. Channel width is this, and channel depth is taken average of several measurement of depth. So if channel width and depth are multiplied, then 1 cubic meter or 1 cubic foot water is being calculated. Then if you put a cork or a piece of thermocol in river water and you are standing on the bank, you can put signs or you can measure the speed of that cork per second or per minute. Suppose per second 2 meters. Thus, if volume is being calculated and speed, then you can calculate this discharge in cumecs or cusecs. These are measured in metric system as well as British system. Likewise, the second parameter, velocity, can also be measured. Just to measure velocity, you put a cork or a piece of thermocol in the mid-valley water, and here the speed can be measured per minute or per second. But if we put that piece of thermocol along the bank, certainly its speed will be lesser than the speed in the mid-valley. That's why at several places, 1, 2, 3, 4, 5, the velocity or speed is measured, then its average is taken, and accordingly the average velocity is also calculated. So these are the two parameters which are used in measuring flood, velocity, discharge during rainy season, and on this basis flood forecasts are being done, and accordingly government prepares different long range, medium range and short range flood control techniques or plans. And the last point of this channel morphology is hydraulic geometry. If there is hydraulic activity, then certainly that will develop some landforms. In channel morphology, there were 3 aspects, and we have studied already 2 aspects. The third one is hydraulic geometry, how flowing water forms a number of shapes in a river valley. Here we will study this, and under this heading there are 4 points. One is channel type, second is channel bed topography, third is channel pattern, and fourth is sediment load. Here in channel type, there are different types of channel. For example, if you are starting from a river source to its mouth, there are different types of channel. For example, one is bedrock or erosional channel. In upper reaches of river, when it is flowing in hilly areas, there is a steep slope, but river water is very fresh and having no sediment load, and it is doing vertical erosion. There the bedrocks of channel are visible, hard rocks and erosional level or erosional surface. Second is alluvial channel. This channel can be seen in the lower segment of a valley, and this consists of a number of deposits like deposition of sand, silt, clay, and thick alluvium is found here. It is called alluvial channel, and it is the result of the deposition of sediment brought down by the river from the upper reaches of a river. Now, on the basis of stability and instability, channels can be put in 2 categories. One is stable channel, second is unstable channel. In mountainous region, channel is stable because it has cut deep its valley, and there is no lateral erosion, hence it is stable and flows along that path for several thousand years. concentrated in lower reaches. When that channel develops meanders, that river channel or bed is not stable, rather it is unstable, and river changes its course. Like here, this river, we will make study of river Rio Grande, how it is changing its course, and its channel is unstable, and it is causing international dispute. And one IR international relation question can be found here. Now, the next point is channel bed topography. In channel bed topography, we can divide the river in two parts. The upper half, where there is no bed topography except waterfalls, cataract, and rapids. But in the lower segment of river, where river develops its meanders, a number of depositional landforms are being developed. Those depositional landforms mainly are counted in channel bed topography. For example, riffle and pool. Here you are seeing that at mouth, the meanders at mouth, in meanders, sediments are being deposited. Why? Because of gentle slope and high amount of load and less channel velocity or speed. That's why some alluvium sandsill clay is being deposited in a linear position, that is along the longitudinal course of a river. This is called riffle. These elongated parallel to the river channel are called riffle, while from between these riffles water is flowing, channel is flowing, and this is called pool. So riffle and pool is very important topography in meanders. Second is sand banks. Sometimes the flowing water deposits its sands, large particles along the bank in a linear position. So this is called sand bank or sand bar. Along the bank, sometimes there are bars and sometimes along banks. So sand bank and sand bars are nearly parallel. Next is sand islands. Sometimes that sand is being deposited in the form of an island, and its formation is due to growth of a vegetation during summer season, dry season in the valley wet. But when there is influx of water, flood water, some things flowing with that water stay with this vegetation, and in that support voluminous amount of sediment or alluvium is being deposited, and it also develops either in circular form or elongated form, that is called sand island, and these are sometimes so high that during flood hours they are visible. Next is shoals. These are the shoals. Shoals are also like sand bars, but these are shallow and these are covered with water during flood hours. Next is sand dunes. As there are sand dunes in desert topography, in the same way sometimes sand dunes are also being developed, and these are due to the deposition of circular shape alluvium. And you can notice riffle and pool, you can notice ripple marks on that sand dune, and this is point bar deposit. If river will cut along this bank, here steep alluvium landscape will be found, that is called bluff, and the material cut by river from this bank will be deposited here, and this is called point bar deposit. Here river will dug deep its valley. So these are the landforms or say channel bed topography. Now one thing more here, channel pattern. In channel pattern there are two types of pattern. One is straight, second is curved. In straight pattern you see that when channel direction is straight, not tortuous. These riffle and pool landforms are developed, and here braided channel is being formed. When braiding takes place, if there is one main or trunk stream, and due to these depositions, the water of this trunk stream is divided in different paths. But further, those channels meet together and make again trunk stream, and if this practice is being repeated, that is called braided channel. For example, river Ganga in lower reaches and especially river Brahmaputra in lower reaches has developed braided channel pattern or straight channel pattern. And second is curved or meandering channel pattern like this. This is curved pattern or meandering pattern. Now, what is meander? Meander means tortuous, zigzag or sinuous path. In meander, on the map, we can calculate meander length. For example, from this peak point to this peak point, this is meander length, and this is meander amplitude. Meander means deviation from a normal course is called amplitude. And one important point here is the calculation of sinuosity index. Sinuosity index means the index showing the nature of or the ratio or coefficient of tortuousness. To calculate sinuosity index, suppose this is a meandering river and this is point A, starting point, and this is point B. From starting and point B, you can measure straight or the shortest distance, that is called air distance, this one. But if you will travel in this river through a boat, that boat will move along this water, and this will be also a length, and this length will be called actual length or real length. It means from point A to B there are two lengths. One, shortest distance length called air distance. Second, actual or geographical length. And to calculate sinuosity index, there is formula that if you put the real distance and divide it by the air distance, the value will be sinuosity index. Here, in this case, for example, the air distance is 2 km, but this real or actual or geographical distance is 4 km. Then you will put value 4 here and divide that by 2. So the sinuosity index will be 2. 2 means just double. And if the air distance or shortest distance is 2, but in case river is flowing in this straight line, straight path, its geographical distance will also be 2. And if you will divide 2 by 2, the sinuosity index will be 1. It means if sinuosity index is 1, then river is straight. But if sinuosity index will increase, its tortuousness or the nature of zigzag will going on increasing, and it will increase up to infinity. What is the use of sinuosity index? It is not a simply geomorphic or morphometric exercise. Rather, it has an applied aspect or applied geomorphological aspect or applied fluvial geomorphological aspect. Why? The more the sinuosity, the more the chances of the straightening of river valley or meander, and the more the chances of the lateral erosion and damage of different cultural landscapes. That's why this is not being studied by geomorphologists, rather by the planners, and they plan to save from flood, to protect the landscape, cultural landscape from erosion and have control on meanders. And one very important point here is that here you are seeing two lines. One line is this red color line and second line is this dotted line. It means the river valley is from here to here. That is a geomorphic fluvial feature or landscape. And in river valley, if there is water, it is called river. But if water is flowing, then that is called channel. Because in one video, we had already discussed difference between valley, channel, stream and river. So here concept should be clear. And here suppose this is one country and on the opposite side of river this is one country. If this is country Mexico and if this is country United States, can you tell the name of this river? You should tell its name, because if you are a scholar of geography in real sense, you should be well aware of the maps and location, because map is tool in the hand of a geography student. It means it is river Rio Grande. But if UPSC changes the countries and in place of USA, here it is written Russia and it is written China, can you tell the name of this river flowing from west to east? You should make stress on your mind and see the map again and again, because it is a penance, it is a meditation of purity. Why? Because you are meditating very important thing, creation of Brahma, creation of that Almighty. It is not creation of man. So here let us come to point. Here this is one country, this is another country, and if buffalo of this country means Mexico goes to drink water and buffalo from this USA comes down to drink water, this is the mid valley. This mid valley divides river in two parts. From this dotted line or mid valley line, to its north it is USA, to its south it is Mexico. It means this mid line in a valley demarcates the natural boundary, or on that basis of natural boundary, it is political boundary drawn on map along the river or mid valley. But what about this red line? If there is one fish that has to travel from this point to this point, so can you tell that fish will follow the route through deepest waters, or that fish will cut short and pass through these point bar deposits or sandy bed? Certainly river will not travel through this sandy bed, rather that will pass through the deepest point, and that deepest point line is called valley thalways, as we have already discussed. So valley thalways is a line joining the deepest points in a river. Thus this valley thalways is the reality of a river, valley thalways, and this reality is in practice on land, because along the meander this valley thalways will be along this meander, along this bluff, and it will practice or continue undercutting of this bluff and shift its bed towards USA, resulting into the land of USA merging with Mexico. And this has happened here. There is one city, Rio Rico, in Texas. Previously, this river, Rio Grande, used to flow this way. Its path was this way straight, but it started cutting its left bank. That's why slowly and slowly it cut the land of United States and deposited on the coast, on the bank of this Mexico. resulting into the shifting of its bed, and this Rio Rico, the city and the area of this Texas, United States, was cut apart, separated, and it fell in the sovereignty of this Mexico, and United States claimed that this Rio Rico city on map belongs to USA, and there was international dispute which was decided, and there was compromise between United States and here Mexico, and ultimately this land was handed over to United States. But you are seeing that the rivers are creating disputes, international disputes between two neighboring countries by shifting their course. And that's why this is very important thing to study, and this channel morphology and this hydraulic geometry is also a very important topic from physical viewpoint, geomorphological viewpoint, as well as planning viewpoint, and it is very important socially, economically, and politically, and its political repercussions and impacts will be studied in detail in political geography and international relations.